So, question 34, part 3. Now, what I would remind you of is how do you do a basic fraction? A basic fraction 3 over x plus 1, yeah?
minus 2 over x plus
2 over.
x plus 4.
Okay, guys, this is 34 part
3.
3. Okay, so 34 part 3 here, okay? So what we have here, guys, is we have two fractions, okay? Now, what I was saying earlier is if you have two really basic fractions, like a third plus, I don't know, 3/4, what you do is one fraction looks over and sees what the other fraction has on the bottom, and then you multiply top and bottom by whatever they have. The other fraction looks over to the fraction to its left, it sees what denominator it has, and then you multiply by that number top and bottom. Then all of a sudden you're going to get a common factor of 12 on the bottom. 1 times 4 is 4, 3 times 3 is 9. The answer therefore would be 13 over 12. This here is no difference. What you have is the fraction, the x plus 1 looks over, and what does it see? It sees what, guys? And if you multiply the bottom by x plus 4, you must multiply the top by x plus 4. Then this one here looks over and sees the x plus 1. So then you got to multiply the bottom by x plus 1 and the top by x plus 1. That makes sense? Now multiply by 3 and you get a 3x plus 12. And then here, minus 2x minus 2. What happens to the bottom? It joins together to make one of them. Some of you multiply it out. It's not necessary to multiply it out, but you can if you want. And then finish this question off. 3x minus 2x. Anybody? 3x minus 2x? And then plus 10 all over x plus 1 by x plus 4. How many people got that out? Many people get that answer? Yeah, same answer if you have it multiplied out at the bottom. X squared plus 5x plus 4. Should be 5x. You forgot the 1 by x in the middle. Okay. It's good. Okay. What's the next question, guys? It was question 35, wasn't it? Yeah. Just hurry up there. Say, guys, it was question 35. This one here. Okay, so which ones was it here? Question part 2. Okay, part 2. So part 2 here, okay, so what we have is I'm going to take the left hand side. You have to make sure that the left hand side ends up equal to the right hand side. So I have n plus bracket n bracket m minus 1 all over 2. They haven't got the same denominator, so I'm going to give them the same denominator. I'm going to put 2 on the bottom and a 2 on top. Now they have the same denominator. I'm going to multiply this one out. I'm going to get n squared minus n. I'm going to get 2n here all over 2. That in turn is going to be equal to n squared plus n over 2. I'm then going to factorize the top. N bracket n plus 1 over 2. Was that what I was asked to turn into? Huh? How do you find out for sure? It says it on the, you can multiply it back out, or you could look at the question here. N bracket n plus 1 over 2. I'm just after getting that right there. Just multiply it out, turn the left hand side into the right hand side. Somebody mentioned 34 part, is it 34 part, 35 part 5? Or part 4? Which one? 5, I think somebody said 5, okay? So, what we're going to do in this one is, once again, take the longer, more complicated side, the left hand side, and your whole goal is to turn the left hand side into the right hand side here. Okay, that's the goal of the question. So, anybody tell me how do you deal with 1 over 2r minus 1 minus 1 over 2r plus 1? How do you manage to deal with that? Any takers? Come on, guys. 2r plus 1 top and bottom. And the other one? 2r minus 1 top and bottom. It's exactly the same way we did the really easy fraction earlier on. You just pick the denominator on the other fraction and use the top and bottom. It's that easy. Multiply out, we get 2r plus 1 minus 1 times 2r minus 2r minus 1 times 1 plus 1. And then you don't have to multiply out the bottom. You can if you want, but you don't have to. 2r minus 2r cancels, and then you're going to get 2 brackets 2r plus 1 2r minus 1. Is that right? Cool. Who got that one now? Good. These are show that questions, so you know if you get them right or wrong, because it has to turn out to be what's on the other side. Yeah. What you mean? Which part, Mark? Here. Here. Okay, because they're not being multiplied, Mark. Because that's not a multiply by 2r plus 1 on top, I can't cross it off with the multiply by 2r plus 1 on the bottom. If I were to wrap them both in brackets like this, then I could do it. But that's only if they're being multiplied. They're not. Okay? So no, you can't do that. Okay, guys. Moving on. What's the next question we're looking at? Question 38. What parts of 38? Oh yeah, good few of them. 2, 4, 5 and 6, isn't it? Okay. Now, the deal is with 2, 4, 5 and 6, you look across and you go, okay, question 2. You have 2x over x squared minus 1 minus 1 over x minus 1. I'm not gonna make a mistake, but I'm gonna make a misjudgment that will cost me a lot of time. Okay? And I'm gonna explain why it's gonna cost me a lot of time. I'd go, oh look, this is grand, guys. Just choose the denominator it doesn't have, top and bottom. Yeah? Choose the denominator it has top and bottom. Likewise, choose the denominator it has top and bottom on the other one. And look, off you go, no worries, yeah? Now, that's not a mistake. A really skilled person can get that out. But I'm saying you're going to have to be really skilled. You can multiply it out, you'll get a cubic equation, you'll break that cubic equation back down again. It's a lot more work than it needs to be done. Now, here's how you save yourself hassle. When you go back to the original question, you do a bit of a scan for factorizing. Is there any part of this question that isn't fully factorized? Which one? X squared minus 1 is not fully factorized. You only start doing that. You only start working on the fractions when every part is fully factorized first. I'm looking at the x squared minus 1, and what I'm thinking is it's the same thing as the difference of two squares. X plus y. Oh, sorry about that. X plus y and x minus y. Okay, so no idea what's going on there. Here we are. So what I'm going to ask you guys to do is we're going to do the same thing, as in we're going to do x squared minus 1 squared is the same thing as x plus 1, x minus 1. Now it's fully, what's that word? Fully factorized, right? Now, remember what we said earlier on. The denominator to the right looks at the denominator to the left. What does the denominator on the left have that the denominator on the right doesn't have? X plus 1. So multiply an x plus 1 top and bottom. Is there anything that the denominator on the left needs? Are both denominators now the same? They are, so there's nothing wrong now, okay? Now look at this. Then you're going to have 2x, and this minus belongs to the top part of the fraction. Multiply it out, and what happens? Minus 1x minus 1 all over x minus 1. x plus 1. And then what we have here is it's going to be x minus 1 on top, is it? Now what happens next, guys? The x minus 1s can cancel. And what's left on top then? Nope. Any number divided by the same number is 1. So 1 is left on the top and x plus 1 on the bottom. Does that make sense? Cool. Okay. Question 4 coming up in a second. Okay. So, question 4. Do you think in question 4 that everything is fully factorized? Is everything fully factorized? No. Factorize the bottom. What do we get? Take out, what can we take out? B into A plus B. And then on the opposite one, A into A plus B. Now, the denominator on the left looks at the denominator on the right. What does it want? What does it see that it doesn't have? What does it not have on the bottom? Hasn't got an A on the outside of the bracket, does it? They both have A plus B. They're both identical in that manner. But the key difference is one of them has an A while the other one has a B. We're going to fix that difference. We're going to give this one an A, but by giving that one an A, we must also give it a second A on top. And multiply by A, that is. And then on the bottom, if we give this one a B, we got to give that one a B. Now look what happens next. On top we're going to end up with A squared minus B squared. And underneath, AB bracket A plus B. It could also be BA, A plus B. That means the same thing. 2 multiplied by 3, same thing as 3 multiplied by 2. Now, can anybody tell me, is there anything that's not fully factorized there? Is the numerator fully factorized? The top. So what can we do with that? Difference of 2 squares. Next, what happens next? And then what happens then? A minus B all over AB. Handy enough? Anybody get that one now? David and 2 people. Okay, 3 people. Okay, we need that number 4. We need more. We need more. We need a higher percentage of people getting them out. Okay. So guys, what about the next part? Now this part is quite interesting. Okay, it's like 2 big questions in one. So it's like 2 questions in one. So what we want to do here, it's not what I wanted. There we go. So I'll just leave that one up for a second. There you go. Just make it a bit smaller. Okay, looking at the next one. 1 plus 2 over x minus 3 over x squared. This is part 6 we're working on now. Okay. What can you tell me about the denominators? Are all the denominators the same? No. So look across and go, if this was an x squared, that'd be great, wouldn't it? What do I need to do to x to turn it into an x squared? Multiply by x top and bottom. And then xx is the same thing as x squared. Okay. Now what happens next then, guys? We're going to have x squared plus 2x minus 3 all divided by x squared. Does that make sense? Just for the top part only. Just this part only. Haven't even gone near the other part yet. We're good with that? Okay. Now, I'm going to look at the bottom part. I'm going to do the same thing. I'm going to look across, and I said, okay, we have 1 plus 3 over x minus 4 over x squared. Once again, be really handy if that was an x squared on the bottom, if this was an x squared on the bottom, which means add another x top and bottom, and then finally we're going to have x squared plus 3x minus 4 all over x squared. Everybody happy with that? And now the question basically becomes what's in the top box divided by what's in the bottom box. A form of massive fraction. Would you agree with that? So here's what we're going to do. Just grab this answer here that we had a second ago, put it underneath. Here's our fraction right here. Now, on a really simple level, what happens when you have one fraction divided by another fraction? An example would be, what would you have done in first year had you had this question? 3/4 divided by 7/8. What would you do with the 7/8? You'd turn it upside down to form it into 8 over 7, and you'd multiply it by 3/4. Now, I can also write this question, the really easy question, I can write it like this. Just 1 second. I can also write this question like this, can't I? Would you agree that that's the same question? And what you told me to do is you grab the bottom fraction, you drag it to the top, and you turn it upside down. Do you think this question should be any different? It's a fraction divided by a fraction. It follows the same rules. So, can anybody make a prediction on my next line? So, the line coming from this part here. Anybody make a prediction? Top fraction remains the same. And then what happens to the bottom fraction, the red fraction? You bring it up, it's multiplying, and what do you do to it? Turn it upside down, so now it's going to be x squared divided by 3x minus 4. You're right, thank you. Sean spotted that I got my signs mixed up on that one there. Thank you, Sean. And that's that done there. Now, remember when you're multiplying fractions, yeah? Do you need a lowest common denominator, or do you need the same denominator to multiply two fractions? 3 by 8, 24. 1 by 7, 7. You just multiply them. Or in the case where you can cross something off, an example would be something like this: 1/3 multiplied by 3 7s. What can you do with the 2 3's? Cancel them, and your answer will be 1 over 7. We're going to apply that same logic that you learnt in your first year of school here to cancel the x squared with the other x squared. That makes sense? In the same way it cancels the 3 with the 3. Yeah? Okay. Is everything fully factorized? No. Fionn? No, because they're being added onto other stuff. So they're technically they're getting added onto other parts. So this x squared here is being multiplied by everything inside this bracket here, while this x squared here is getting multiplied by everything in there. So it's only when they're multiplying everything on the top or everything on the bottom that you're allowed to cross them off. Okay. So can anybody tell me, is this fully factorized? How do you fully factorize it? Reference number minus 3. It's going to get me x plus 3, x minus 1 on top. A reference number of minus 4. Anybody? X plus 3, x minus, oh sorry, no, my bad. X plus 4, x minus 1. Everybody at this stage knows how to factorize those type of equations, okay? Now, what happens next? Question: are you allowed to cancel these two x's? Why not? They're not being multiplied by everything on the top, and the other x on the bottom is not being multiplied by everything on the bottom. Therefore, you cannot cross them off. Okay?